Okay. From the 403 to the HAZ, Mr. Nelson here to round out our lesson on function transformations. And we are working with the transformation of our function y or our function f of x such that, we have to use red here, a f of, and then we're going to have b x minus h, oh my goodness, plus k. So we have explored that a is going to manipulate our y coordinate, and any a number that is bigger than 1 or bigger than 1 is going to be a stretch. Any fractions or decimals, numbers between 0 and 1 for a, are going to lead to a compression along the y-axis. And when a is negative, we're going to get a reflection on the x-axis. B kind of behaves in an inverse manner on the x-axis. So when b is a fraction, we're actually going to divide that fraction by 1 to get the actual horizontal stretch that we're going to apply. So if b was 1/2, we would actually do 1 divided by 1/2, which is 2. So we would multiply all of our x coordinates by 2. They're doubling. So the length of our function will actually double if b is 1/2. If b is 3, we divide 1 or 3. We divide 1 by 3, and then we're going to get a vertical or horizontal compression by a factor of 1/3. So we're going to take all the x coordinates, divide by 3. And that leads us into our horizontal and vertical stretches. Horizontal stretch horizontal translation or horizontal shift, and vertical shift or vertical translation. And recall, important for us to recognize that A and K are going to change our y coordinates or manipulate our y coordinates for a graph, and B and H are going to change my x coordinates. Now, once we start to actually combine transformations, because so far we've just been seeing one at a time, when I get maybe say an A transformation combined with a K, I'm always going to do the stretch or the vertical the vertical stretch or the horizontal stretch first. So I'm going to multiply my function by whatever number I need to, and then I'll add my K. But let's get into what adding and subtracting H and K actually does. So if we recall from quadratics, we had P and Q, and P and Q represented, in a quadratic function, the vertex. So if I had y is equal to x minus 2 squared plus 3, that would represent a vertical translation of my baseline y is equal to x squared, where I would move my vertex, my original would be right here, and I would move mine 2 to the right, 2 units to the right, because h is going to be equal to 2. And then if I was going to go to the left, I would have an x plus 2, because that would represent minus negative 2. But you just have to know that it's opposite whatever sign you see there. So 2 is negative here, so we're going to move it to the right, and then we're going to move it up 3. So we'll actually get a function that looks like this at the end. And H and K behave exactly the same way. We can just apply H and K to all functions. So let's say I have a function, a defined function with a defined domain and range that goes something like that. Just go with that. Okay, and I'll say that I have coordinates -5, 5 here. I'll have a coordinate of -2, 1. I'll get 2, 1 here, and then we'll say 4, 3 here. So for this function, let's say I have a transformation. Well, we'll do two transformations one at a time, but let's start with our table of values for this function. So I have 4 sets of x coordinates and 4 sets of y coordinates. My x coordinates are -5, -2, 2, and 4. So I'm just going to put those in order here. -2, 2, and 4. And then on my y coordinates, I'm going to have 5, 1, 1, and 3. So let's say I have a function. So this is, we'll say that this is, or f of x, y is equal to f of x, okay? This is f of x. And let's say I have, this is f of x, let's say I have y, a new function y, or transformation, that's equal to f of x minus 3. Okay, so in this case, I am subtracting from f of x. This is all inside the bracket, so that would all be in here. So I'm clearly outside the bracket, and I'm subtracting 3. So I'm k, and k is minus 3. K means I'm changing my y coordinate. So my new function here, x and y, I'll keep my x's the same, and I'm going to subtract 3 from each of my y's. 5 minus 3, 2, minus 2, minus 2, and 0. And then if I were to graph my new function at -5, I'm going to be at 2. At -2, I'm going to be at -2. Right here. At 2, I'm going to be at -2. And then at 4, I'm going to be at 0. So if I were to graph this, it would look something like this, where I can see that all I did was lower my function 3 units. So what if I were to now do my other translation, the word I couldn't recall before, shift or translation. What if I were to do y is equal to f of x minus 3. Okay? So in this case, I am inside the bracket where I'm subtracting. My number is not in front of x, so I have no b. B is just 1, but h is 3. So this means that because it's the opposite, we've talked about this, I'm going to actually shift to the right 3 units. So my new function, whoops, I erased my old data points. So I was at -5, -2, 2, and 4, and 5, 1, 1, 3. Hello, sir. Sure. Make another video.
Oh, wow.
Were you playing that b-ball?
Yeah, dude.
Sweet. I'll come talk to you in 5 minutes if you're going to be around.
I'm going to be in my office, dude.
Okay, we'll come see you. Mr. Fisher, ladies and gentlemen. So I'm going to keep my, in this case, I'm changing my h. Okay, so I'm actually going to use green because I'm changing my h. So I am going to manipulate my x coordinate in this case. So -5 plus 3 is -2. -2 plus 3 is 1. 2 plus 3 is 5. 4 plus 3 is 7. And I will keep my y coordinates, in this case, just because this is the only translation I have, the same. And then if I were to graph this one at -2, I have a y of 5. At 1, I am at 1. At 5, I am at 1. And at 7, I am at 3. So, as we can see, we have now just a horizontal shift. And that's what h and k do. Now let's look at a combination of the two. And maybe we will play with a linear equation this time. So let's say that I have f of x is equal to x plus 2. Okay? It's a linear equation, and I'm going to make a table of values for it. X, y, and I'm just going to choose random. -2, -1, 0, 1, 2 might go 2. So, -2 plus 2 is going to spit out my f of my y, which is also my f of x. I should actually not confuse you. I should call this f of x. F of x and y are the same thing, essentially, sometimes. So, negative 2 plus 2, there. Negative 1 plus 2 is 1, 0 plus 2 is 2, 1 plus 2 is 3, 2 plus 2 is 4. And if I graph this guy, it will look something like, what is that? Okay, it'll look something like that. And it will probably go on forever. Well, it will go on forever in either direction if I don't define the domain thing. So there's what my function looks like. So now let's say that I have a transformation of that function of f of x plus 2 plus 2. There we go. Okay. So what I'm going to do, if I want to figure out what this new transformation looks like I can already tell you, I'm moving left 2 units and up 2 units. H here now is negative 2 because you get the plus from a negative 2. So H is actually negative 2, which means we're going left, but you just go the opposite sign. So I'm going to push this whole graph 2 to the left, and I'm actually going to lift it up 2. But what would that look like with my existing coordinates? Well, all the x's, the h I'm going to apply to the x's. So I'm going to subtract 2 from each of my x's. And I'm going to get negative 4, minus 1 minus 2 is negative 3, negative 2, negative 1, and 0. And then I'm going to add 2 to all my y's. 2, 3, 4, 5, 6. And then if I were to go and graph that, at negative 4, I'm at 2. At negative 3, I'm at 3. At negative 2, I'm at 4. At negative 1, I'm at 5. And at 0, I'm at 6. It's going to look something parallel, but shifted. Okay? And that is, and you can see here that my y-intercept went from occurring at f of x is equal to 2 to occurring at f of x is equal to 6. So I've actually, this shift caused an increase of my y-intercept by 4. But that's just something you can kind of pick up on. So this is what h and k do. It's pretty straightforward. And in our next video, we are going to combine transformations of all 4. We're going to have both reflections, A and B. We're going to have vertical and horizontal stretches. And we're going to have translations or shifts using h and k. And I will see you then.